Hi Science 30, it's Mr. Riley here. We're going to take a look at series and parallel circuits and measuring the current and voltage at different points in those circuits. So up here on the screen here, I have a series circuit on the left and a parallel circuit on the right. We looked at these circuits before when we looked at the resistance video. So if you haven't watched that video, I suggest you take a look at the resistance video first. So what we can see here is these are two models of circuits, and what they're doing is they're making an analogy between electrical potential and gravitational potential. So in these models, we see that on the left where I put 9 volts over here, this is essentially a battery. So the battery is pumping up the potential energy of these little charges, and then as we move through the circuit, we run into some resistors, and those resistors, at each of those resistors there is a drop in the voltage or a drop in the potential energy, and it works a little bit different whether we're talking about series or parallel. So let's go and look at the diagrams. So in the resistance video, we already calculated R total for each of these. We saw that series circuits have a higher resistance than parallel circuits. Okay, and so what we're going to do next is we're going to calculate the current. And in order to do that, we have to recognize what's the total voltage available to the circuit, and that is going to be 9 volts for both of these. So the voltage across my my source, that's my total voltage available to the circuit. Okay, so I'm going to go to green here, and I'm going to calculate the total the current in the circuit. So I'm going to be calculating these A1 on this one right now. So the total current, okay, at A1, we're going to use Ohm's law. Okay, so we're going to take I equals V over R. We're going to take that total voltage of 9 volts, and we're going to divide that by the resistance of 40 ohms. So I'm going to quickly plug that in my calculator. We're going to do 9 divided by 40, and we get 0.225. So the current over here is 0.225 amps. Okay. Now, I have 3 different, moving over to the right, to the parallel circuit, I have 3 different ammeters. If I want to measure the total current, I'm going to use A3 here, because if I trace the pathway of electricity through these 2 parallel circuits, I can see that there's overlap where A3 is. So A3 is going to give me the total current for this circuit. So let's do the same thing. We're going to use Ohm's law. I equals V over R. We're going to get that same 9 volts, and we're going to divide that by 7.5 ohms. Okay, so 9 divided by 7.5 is 1.2. So we see here that there's that relationship that we've talked about between resistance and current. If I have a higher resistance, I'm going to have a lower current. That's what happens over here in the series circuit. If I have a lower resistance, then I'm going to have a higher current, which is what we see happen with the parallel circuit. Okay, so now what we're going to look at is we're going to look at the voltage, and there's something that we want to recognize here about these diagrams that's going to help us. So we see here in the series diagram how the voltage drops in 2 sections. Okay, so we're looking over here. And so the total voltage drop in your series circuit is going to be equal to the total voltage rise that there is where there's the battery. Okay, now we see a little bit something different on the parallel circuit. So if I'm looking over here on the parallel circuit, each parallel circuit drops with the complete voltage. So each parallel circuit is going to have that complete potential energy and that complete voltage from the source to work with. So there's going to be a voltage drop of 9 volts for each of these Whereas over on this one, there's going to be a drop of 9 volts over both of them. So this gives us something to look at here. So first thing that we're going to take a look at here is the voltage reading that I'm going to have here is 9 volts, and the voltage reading I'm going to have here is 9 volts. So for V1 and V2, both 9 volts. Okay, so this is related to what's called Kirchhoff's voltage law, and this is telling us that the this total voltage, it's the same in every parallel circuit. So I'm going to write that down here. Now, what we're going to find over here is that the total voltage drop is going to be shared between these two. So let's do the math here for V1 and V2. So for V1, so voltage, so for V1, we're going to do V equals I times R. So we know our total current was 0.225 amps. And our total resistance for R1, so we're looking at this one up here, is 30 ohms. Okay, so we're going to take 0.225 times 30. And we're going to get 6.75 volts. And then now I know that V2 is going to be 9 volts minus 6.75, so it's going to be 2.25. But let's check out and see if I'm right. So for V2, V equals IR, we're going to get that 0.225 amps, and we're going to use 10 ohms this time because we're talking about this one up here. Okay, and so when I do that in my calculator, I'm going to do 0.225 times 10. Well, look at that, 2.25, just like I said. So V2 is 2.25 volts. So this one was 6.75, this one was 2.25, and those both add up to our 9 volts. Okay, now that's one of the things that's fundamental difference between series circuits and parallel circuits. So the voltage is shared. Total voltage is shared between the resistors. Okay, so those two things are key. Now let's go back and look at the current here. So I mentioned before that, oops, I'm having trouble with my colors here. So I mentioned before that if I wanted to measure the total current of the circuit, I could measure A1 over here on my series circuit. I could measure current anywhere on this circuit because it's all one current. And so key thing about series circuits and current is that current is the same everywhere at all points in a series circuit. Okay, now that's not true for parallel, so we got to go solve for A1 and A2 for the currents. Okay, so let's solve for A1. So this is ammeter number 1. So we have a 30 ohm resistor and a 9 volts of electricity, 9 volts. So we're going to do I equals V over R. Okay, so we're going to take that 9 volts and we're going to divide that by 30 ohms. Okay, so 9 volts divided by 30. Okay, and we're going to get 0.3. So A1, we're getting 0.3 amps. Okay, for A2, okay, we have a 10 ohm resistor. So we're going to do I equals V over R. We're going to do our 9 volts divided by 10 ohms. Okay, and we put that into our calculator. Okay, 9 divided by 10, okay, is 0.9. Okay, so this one was 0.9 amps. This one was 0.3 amps. And guess what happens when we add those two together? Okay, we get 1.2 amps, which was the total that we calculated for A3 up here. So this one was 1.2 amps. So in parallel circuits, current is additive. Okay, so I know that's a lot for a short video, but if you need to watch it a couple times, do that. There's plenty of exercises for you guys to work on. Good luck.